Alright, in today's video, I will try to answer and explain about the quiz 5 of solid mechanics subject. Then this is the system that we have. It is the beam with two load. This is the first and the second load with the support. The first support is roller and the second support is spin support. Then we need to derive the slope and electric curve equation of ACD and find the slope at A that happened here and the deflection at A. A is the middle of the beam. As usual, the first thing that we can do to find the answer is determine the free body diagram because it's important. Then this is the free body diagram that I got. Load A, the support C, the support D, the support B, then Y, the reaction force for D is only one since it's in support. It's because the Fx, the F at acceleration and negative because there is no force at X direction, so Fx is equal to 0. Then I just neglect this reaction force at X. So the support D only have one action force. To get the FVD, I divide the beam into two parts and divide it again into two parts to find the moment of its load. The first part is load when x is less than 0. I mean x greater than 0, but x less than a is the moment. This is to find the moment. Moment is minus 15x. We do the same thing with the second part, and finally we cut the moment. Then to find the deflection, to find the slope, we just integrated the equation of moment. To find the slope, we just need to integrate it once. Then to find the deflection, we just to integrate the slope equation once. Then we got this value. We do the same thing. I did the same thing on the second part. I just integrated twice to find the deflection. I just integrated once to find the slope. And we cut this, the y equation, the slope equation, then find the to find the equation when the deflection, the slope at at some point, we need to determine boundary condition. This is boundary condition that use when x equal to a is this part, the distance between load A and traction force at C. This is have 0.3 meter. The y is equal to 0. There is no deflection at point C. When x is equal to a, the dy over dx equal to dy over dx. This is the slope. This is from the first part. This is from the second part. The or we can call this is the theta 1 and equal to theta 2. There is equal to a. There is the slope is the same in here. The slope in here between the part 1 and part 2 equation is the same. Then when x equal to the y1 equal to y2, so there is no deflection from the first part. Y1, y2, this is from the first part, is the second part. This is part 1. Part 1, this is part 2. I mean, this part 2. boundary condition and x equal to L over 2 and dy dx is equal to 0. This is L of. Now I start working the last boundary condition when x equal to L over 2 dy over dx is equal to 0. So we can use this boundary condition to the first integration from the second part. That we got minus a times 2a plus c equal to 0. Why this is 2a? Because L over 2 is equal to 2a. Since L equal to 4a. When it's multiplied by 50, rearrange term and multiplied by 50. And finally, the C3 is equal to 30a squared. Then I use this value to find the C4. Put to the C4 equation while C4 is equal to 7.58 to the power of 3 minus C3a. Then we got this value and C4 equal to minus 22.5a to the power of 3. Because I also distribute the value of C3 to the C1 equation. C1 is minus 7.5a to the power of 2, 7.5a squared plus C3. Then I got C1 equal to 22.5a squared. Then I distribute the C1 substitute to the C2 equation. Then I got C2 is equal to minus 20a to the power of 3. Now I know that the value for all the constant is already known. Then I just substitute value to the equation from the previous slide. And this is what I got. This value that I already substituted with constant. I constant number. Then this is from the part 1, and this is from the part 2. This, this equation is equation to find the slope. This equation is the equation to find the deflection. Why this is AI over 1000, not only AI divided dx, because this 1000 is because in this value is still in kilonewton. So I just divided by 1000. Now in the question asks to find the slope at A. This is the condition at A, that at A the x is equal to 0. This is to find the slope, so I use this equation to here and put all of the number. This is the same. And put all of this number to this. This will be cancelled out because x equal to 0, and this is just you put the value of a, since a is equal to 0.3 meter, and we got this. Uh, a times e times inertia equal to 2.025. We arrange the term, and slope equation that I got is a equal to 12.57 over a times 10 to the power of 6 radian. Then the question also asks to find the deflection at E. This is the condition that happened at E. E x is equal to 0.6. We can use this equation to find the deflection at E, because E is happening in the second part. It does input the value of x and A to the equation. I think this is Miss Y. This is Y E times E times inertia is equal to this value. This value is equal from this after we substitute with 0.3 and x with 0.6. We got this 0.2025. We then I rearrange the term. Then what I got is the equation of deflection when y is equal to 1.257 over 8 times 10 to the power of 6 meter. Okay, that's all. If I want to I want the exact number of the deflection slope, I just distribute value of E. The value of E is depend on the material that we use for the beam, or it's usually given in the question. Okay, that's all. Thank you.